Welcome to this expert-level training session. Today, we are focusing on identifying specific, real-world scenarios for common artificial intelligence workloads. Welcome to this comprehensive training on identifying artificial intelligence workloads. As enterprise architects, our goal is to build applications that solve complex business challenges. To do this effectively, we must master the core AI workloads. An AI application is a software solution that leverages advanced AI techniques, such as natural language processing, computer vision, speech recognition, and information extraction, to perform tasks that typically require human-like intelligence. These systems go far beyond traditional programming. They can reason over data, perceive their environment, learn from context, and respond to inputs in a highly adaptive manner. Rather than writing millions of lines of deterministic code to handle every possible user interaction, modern developers orchestrate specific AI workloads to handle complex variables. By understanding the distinct capabilities of generative models, agentic workflows, text analytics, speech synthesis, and computer vision, you can architect solutions that profoundly transform enterprise operations. Before we dive into specific models, it is crucial to recognize that the foundational infrastructure for all these workloads relies on robust cloud platforms like Microsoft Azure. Azure provides the essential security, networking, data storage, and compute scaling required to host these resource-intensive capabilities safely. Whether you are building a mobile app that scans business cards or an enterprise workflow system that processes legal contracts, we must identify the exact workload required to maximize efficiency. In this session, we will break down each major workload, defining how they function, and exploring specific real-world scenarios where they deliver maximum business value. While identifying workloads is an architectural task, it directly impacts your application code. Your codebase will route user inputs to specialized API endpoints based on the workload. For example, text inputs may route to a language model's REST API, while image data routes to a dedicated computer vision endpoint for parallel processing. Take a look at the flowchart on your screen. This outlines the landscape of enterprise AI applications. A single application can route data to multiple specialized workloads, including generative AI, text analysis, speech, vision, and information extraction. All of these powerful workloads securely rely on the underlying Azure cloud infrastructure. Our first major workload category is generative AI. Generative AI is a revolutionary branch of artificial intelligence that enables software applications to generate entirely new, original content. While we often associate this with natural language chatbots, it also includes the generation of images, video, and computer code. This workload is powered by large language models, or LLMs. LLMs are trained on massive datasets and work by encapsulating the deep semantic relationships between words, allowing them to mathematically predict the most probable text sequence in response to a user's prompt. So what are the primary scenarios for this workload? First, we have marketing content creation. Companies use generative AI to automatically write product descriptions, blog posts, and social media content, saving countless hours while ensuring brand consistency. Another massive scenario is code generation. Developers use tools like GitHub Copilot to generate code snippets, suggest functions, and write entire modules based on simple natural language prompts, radically accelerating software development lifecycles. We also see this workload heavily utilized in personalized learning and tutoring environments. Educational platforms leverage generative models to create custom quizzes, detailed explanations, and personalized study guides tailored to a specific student's learning style. By utilizing generative AI, organizations transition from simply retrieving static data to actively creating high-value, dynamic assets on demand. Generative AI essentially acts as a highly advanced reasoning engine, capable of synthesizing vast amounts of contextual data into perfectly formatted, human-readable outputs in milliseconds. To implement a generative workload in your code, you utilize a cloud SDK, such as the OpenAI Python library. You instantiate a client object and call the completions endpoint, passing an array of message objects that include the user's prompt. The API then returns a JSON payload containing the freshly generated content for your app to display. This visual demonstrates the core generative workflow. A user submits a natural language prompt into a large language model. The model utilizes probabilistic prediction to generate completely original assets, such as marketing copy, software code, or personalized study guides, driving immediate business value. While generative AI models provide raw intelligence, our next workload, agentic AI, turns that intelligence into automated action. AI agents are software applications built on top of generative AI that can reason over natural language, automate tasks by using specific tools, and respond to contextual conditions to take appropriate action. An agent consists of three core elements: a large language model serving as the brain, a system prompt providing strict operational instructions, and external tools. These tools include knowledge retrieval systems like search engines, and action tools that enable the agent to modify the outside world. Common scenarios for agentic workloads are transformative. A primary use case is automated customer support. Businesses deploy AI-powered virtual agents that operate 24/7, understanding complex customer inquiries in natural language, querying back-end databases for order status, and executing refunds without human intervention. Another powerful scenario is complex workflow automation, where agents break large goals into structured steps. For example, an agent could monitor an inbox, extract meeting requests, check availability across multiple calendars, and automatically dispatch calendar invites. By giving the AI model access to tools through protocols like the Model Context Protocol, we elevate the system from a passive chatbot into an active, highly capable digital employee that can reliably execute multi-step enterprise workflows. This bidirectional communication loop between the language model and your external systems is the absolute defining characteristic of agentic architecture. When coding an agentic workload, developers use orchestration frameworks or the Foundry Project API. Your code defines the agent's tools by passing JSON schemas of your local functions to the model. The model then pauses its text generation to return a tool_call request, instructing your code to execute a specific function and return the result. Observe the architecture of an agentic AI workload. A user goal request enters the AI agent logic. The agent leverages its reasoning engine, but crucially, it branches out to execute actual tools, like database queries and API executions. The data from those tools returns to the reasoning engine, resulting in a successfully completed automated workflow. Our third workload focuses on making sense of existing data through text analysis, a highly specialized subset of natural language processing, or NLP. While generative models create new text analysis solutions are designed to automatically examine unstructured written text to extract useful information, structure, and insights. This relies heavily on tokenization and semantic embeddings to map relationships between words. The scenarios for text analysis are highly prevalent in enterprise data processing. A major scenario is sentiment analysis and opinion mining. Organizations automatically route thousands of social media posts, product reviews, or customer support tickets through an NLP model to instantly categorize them as positive, neutral, or negative, allowing teams to react to public relations issues in real time. Another absolutely critical scenario is personally identifiable information, or PII, detection. Before organizations share datasets or analyze chat logs, they use text analysis to automatically identify and redact sensitive details like names, physical addresses, and financial account numbers, ensuring strict compliance with global privacy regulations. Additionally, workloads like entity detection are used to extract key terms, people, and geographic locations from massive legal contracts or research papers, transforming dense, unreadable text blobs into highly structured, searchable databases for downstream analytics. These purpose-built language tools are favored over generative models for these specific workloads because they consistently return highly predictable, deterministic results. Implementing text analysis often involves using dedicated, deterministic APIs like the Azure Language SDK. Your application code passes an array of text documents to the specific service endpoint, such as the PII redaction API. The service returns a structured JSON object containing the exact character offsets of detected entities and the redacted text. This diagram illustrates the text analysis processing pipeline. An unstructured data blob is fed into the NLP text analysis engine. The engine executes highly specialized, deterministic tasks like sentiment categorization, entity extraction, and PII redaction. The result is structured actionable intelligence that databases and analytical systems can natively ingest. Moving beyond text, we encounter the speech workload. Speech capabilities enable applications to detect, interpret, and generate spoken language, creating highly intuitive and accessible user experiences. This workload encompasses two primary technologies: speech recognition, which converts audio waveforms into written text using acoustic and language models, and speech synthesis, which transforms text into natural-sounding audio through text normalization, linguistic analysis, and neural vocoders. The business scenarios for AI speech are incredibly diverse. In healthcare, clinical dictation is a massive workload. Doctors speak patient notes aloud, and the AI transcribes the audio into accurate medical text in real time, drastically reducing manual data entry. In customer service, call transcription allows contact centers to transcribe live calls, enabling managers to instantly analyze conversations for compliance and sentiment. In media and entertainment, automated captioning uses speech recognition to generate live subtitles for video streams, ensuring accessibility for global and hearing-impaired audiences. Conversely, e-learning platforms utilize speech synthesis to automatically generate narrated lessons and pronunciation feedback, scaling content production without the need for expensive recording studios. Together, these technologies enable seamless voice interactions. These speech endpoints manage all of the complex network communication and audio buffering seamlessly, allowing developers to focus entirely on the application's core user experience. To build a voice-enabled application, developers utilize the Azure Speech SDK. For speech-to-text, your code initializes an audio configuration linked to the device's microphone and creates a speech recognizer object. You invoke an asynchronous recognition method, which captures the audio stream, transmits it securely, and returns the transcribed text. The diagram displays a complete, end-to-end voice loop. User-spoken input undergoes acoustic and language modeling to produce an accurate text transcription. This text hits the AI processing core. The resulting text output generation is fed into a neural vocoder for speech synthesis, finally delivering a natural spoken audio output back to the user. Our fifth workload is computer vision, an incredibly powerful area of AI that focuses on enabling machines to interpret, analyze, and understand visual information from the physical world. By utilizing advanced algorithms like convolutional neural networks and modern vision transformers, these models process the numerical pixel values in images and live camera streams to emulate human visual perception. The real-world scenarios for computer vision are reshaping physical industries. In the automotive sector, autonomous vehicles absolutely rely on computer vision models to detect and respond to traffic lights, road boundaries, and pedestrians in milliseconds. In retail, smart checkouts use camera feeds to accurately identify the specific products a customer places in their basket, enabling frictionless, automated billing. Security and access control systems utilize facial recognition to authenticate users for secure facility entry. Furthermore, with the rise of multimodal models, we see advanced visual search workloads, where a user can take a photograph of an item and the application instantly identifies the object and searches an inventory database for exact matches. We can even utilize video generation models to create short animations from text descriptions for rapid visual prototyping. Computer vision effectively bridges the gap between digital software and the physical environment. The model's inference engine decodes the image, extracts the semantic features, and returns a structured analysis of the visual elements. When working with computer vision models programmatically, your client application must capture and encode the visual data. Often, your code will convert a captured image into a base 64 encoded binary string. This encoded string is then embedded directly into the JSON payload alongside your system prompts and transmitted to the vision-enabled API. This workflow highlights computer vision applications. A live camera feed or static image enters the vision transformer model. The model conducts deep pixel and feature analysis, which empowers critical physical systems like autonomous vehicle tracking, smart retail object detection, and highly secure facial authentication frameworks. Our final workload is AI-powered information extraction. Organizations possess massive amounts of unstructured data locked away in scanned documents, PDFs, audio recordings, and videos. Information extraction combines computer vision techniques, specifically optical character recognition, or OCR, with advanced natural language processing to detect text in images and semantically map that text to specific, structured data fields. The most prominent scenarios for this workload involve business process automation. In financial document processing, AI solutions analyze scanned invoices to automatically extract critical fields like vendor names, transaction dates, line item descriptions, and tax totals. Similarly, for expense claim processing, applications can instantly read photographs of crumpled receipts and extract the exact purchase amounts and dates for automated reimbursement workflows. By converting unstructured media into machine-readable JSON data, businesses completely eliminate manual data entry. As you design these powerful AI workloads across generative, agentic, speech, vision, and extraction scenarios, you must always adhere to responsible AI principles, ensuring your systems are fair, secure, and fully accountable. Thank you for joining this expert training module. Please like, subscribe, and share this video with your network. I highly encourage you to visit quicktechie.com for premium certification prep, featuring extensive Q&A banks, ebooks, audiobooks, training labs, and expert interview guides. Master these workloads and build the future of AI. To execute document extraction in your code, you use specialized APIs like Azure Content Understanding or Document Intelligence. Your script passes a PDF file to a pre-built analyzer endpoint. The service applies your predefined extraction schema and returns a structured JSON object containing key value pairs, which your code easily inserts into a SQL database. Our final flowchart maps the information extraction workload. An unstructured invoice image passes through OCR to produce extracted raw text. Crucially, this text undergoes AI semantic field mapping to perfectly identify attributes like vendor name and totals. This results in structured JSON output that is safely saved directly to a relational database.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.